I'm John Castillo. Let's do some math. In the last video, we looked at how to solve problems using the product and quotient rules. In this one, let's look at combinations of those rules. So in this first problem, we have 5 to the third times 5 to the ninth divided by 5 to the fourth. Now, by definition, we can write this out as 5 times 5 times 5 multiplied by 9 factors of 5 in the numerator, and all of that is divided by 4 factors of 5. But instead, let's cut out a lot of the work and use the product rule and write this as 5 to the third plus 9 divided by 5 to the fourth. Now, 5 to the third, 3 plus 9 is 5 to the 12th, and that's divided by 5 to the fourth. This is now a quotient rule problem, and since the bases are the same, we subtract the exponents. So this is 5 to the 12 minus 4, or 5 to the 8. Next, let's look at 7 to the 10 over 7 squared times 7 to the first times 5 cubed. Okay, there's nothing really to do in the numerator, but in the denominator we have two factors with the same base. We can combine those. So 7 to the 10 over 7 to the 2 plus 1 times 5 cubed, which is 7 to the 10th over 7 cubed times 5 cubed. Now, with these two, we can use the quotient rule, let's rewrite this first. 7 to the 10 over 7 cubed times 1 over 5 cubed. Because anytime you have A times B over C times D, this can be rewritten as A over C times B over D, or it could be written as A over 1 times B over 1 times 1 over C times 1 over D. Any of these combinations. So we can separate it this way, but we don't have to. All right, let's use the quotient rule on this first part here, and that's 7 to the 10 minus 3 times 1 over 5 to the third, which is 7 to the 10 minus 3 is 7 to the 7th times 1 over 5 to the 3. And let's put this back together. That's going to be 7 to the 7th over 5 to the third. There's nothing really to do with the 5 to the third because there is no other factor or exponential expression with a 5 base. In this last one, we have 2 to the 5th times 3 to the 7th times 10 to the 5th times 5 cubed over 2 squared times 3 cubed times 7 squared. Now, again, we can rewrite this as separate division problems. We can write this as 2 to the 5th over 2 squared times 3 to the 7th over 3 cubed times what's left, because all three of these exponential expressions have no counterpart in the denominator. So let's just keep it as it is, 10 to the 5th times 5 cubed over 7 squared. Now, with these two, we can use the quotient rule. So this is 2 to the 5 minus 2, and multiplying 3 to the 7 minus 3 times all of that, 10 to the 5th times 5 cubed over 7 squared. This simplifies to 2 cubed times 3 to the 4th, and then this is still there, 10 to the 5th times 5 cubed over 7 squared. And then we put it all together. Since any number, any whole number, or any expression like this can be rewritten as 2 cubed over 1 times 3 to the 4th over 1. Any number like this is actually a fraction. But we suppress the denominator 1 because there's no point in writing it. Ten to the 5th times 5 cubed over 7 squared. And now we're going to multiply the numerators. 2 cubed times 3 to the 4th times 10 to the 5th times 5 cubed over 1 times 1 times 7 squared, or 2 cubed times 3 to the 4th times 10 to the 5th times 5 cubed, all over 7 squared, and that's it. All of this and much more is covered in the Pre-Algebra workbook series that's linked to in the description. Thank you for watching.